Lesson 3.4, using the quadratic formula. All right, let's solve ax squared plus bx plus c equals 0. We're going to solve it by completing the square. So our first step is we're going to subtract c from both sides to get the x's just on the left. Then I need the number in front of x squared to be 1. So we are going to divide both sides by a. We end up with that. Next, I need to complete the square. So I'm going to add half of my b. So b is actually now b over a, and half of that would be b over 2a, because it's 1/2 times b over a equals 1b on top, 2a on bottom. I'm going to add that squared to both sides. All right, then we're going to rewrite. It says a perfect square. We'll take the x, the plus, and that number squared. And on the right side, we have b squared, 2 squared, and a squared. So b squared over 4a squared. And I need a common denominator, so I multiplied by 4a, top and bottom, so that I had a common denominator of 4a squared. I could combine that fraction into a single fraction, since they have a common denominator. It'll be b squared minus 4ac over the 4a squared. Then I could square root both sides. When I do so, I have to remember the plus and minus. And then I'll subtract the b over 2a. Inside of the square root, it's the square root of the top and the square root of the bottom. But the square root of the bottom, square root of 4 is 2. The square root of a squared is a, so that's why it's 2a on the bottom. And then I could combine that fraction into 1 and end up with that answer. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Here's the result from the previous slide. X equals negative b plus and minus square root of b squared minus 4ac all over 2a. This is called the quadratic formula and always works with quadratic equations. Always works. Wow. The part under the square root, that's this b squared minus 4ac, that's called the discriminant and tells you what kind of solutions you're going to have. So if the b squared minus 4ac is greater than 0, we'll be taking the square root of a positive number, and it's plus and minus that, so we'll have two real solutions that are different. If the discriminant is 0, we'll have the square root of 0, which is 0. So we'll just have exactly one real solution, which would actually simplify to be negative b over 2a, because the square root part's 0. And if the discriminant is negative, we'd be taking the square root of a negative answer, which is imaginary, and we have the plus and minus, so we'd have two distinct imaginary solutions. So what types of solutions do we have for this equation? So notice it's saying what types. It doesn't actually ask us to solve it yet. So that's just the discriminant. So it'll be squared minus 4ac. Well, this is a, b, c. So b is 3, a is 5, and c is negative 4. So that's 9, and I think that would be 80. 9 plus 80 or 89. That is definitely bigger than 0. So if our discriminant is bigger than 0, it is 2 real solutions. Oh, hey, they want us to solve this. All right, let's use the quadratic formula. First of all, we have to set it up so that it equals 0. So we'll subtract the 4 so it equals 0. So now we're in standard form. This is A, B, C. Our quadratic formula is x equals negative b plus and minus square root of b squared minus 4ac all over 2a. So b is 3, a is 5, c is negative 4, a is 5. Need space, I'll write it over here. That'd be negative 3 plus and minus the square root of 89 over 10. And you say, oh, can we simplify the square root of 89? And try to think of what times what makes 89. Nothing, that's a perfect square. Therefore, that is the solution. We have two of them. Negative 3 plus the square root of 89 over 10, and negative 3 minus the square root of 89 over 10. Notice it's two real solutions. All right, this one just says solve, so let's solve this using the quadratic formula. This is A, B, C. Quadratic formula is negative b plus and minus square root of b squared minus 4ac all over 2a. So it's negative, b is negative 6, so it's negative a negative 6. B is negative 6, a is 4, c is 3. A is 4. Negative and negative is 6. And the square root simplifies to be negative 12. Bottom is 8. Oh, hey, could we simplify that negative 12, square root of negative 12? That'd be square root of negative 1. And then 12 is 4 times 3. Okay, so the square root of negative 1 is I. Square root of 4 is 2. Looks like that. Hey, notice everything is divisible by 2, so we could reduce everything by 2 to have it 3 plus or minus 1 square root of 3i over 4. Usually you'd write this as 3 over 4 plus and minus the square root of 3 over 4i to put it in standard form for imaginary numbers. All right, in this problem, we want to find a possible pair of integer values for a and c so that our equation has the number and type of solutions. We want one real solution. All right, so this is the type of solution, so that means we're going to use the discriminant. So that is b squared minus 4ac, and one real solution, that was when it equaled 0. Notice b up here is negative 12, and we're supposed to find an a and a c. So I'm going to add the 4ac to the other side. And then I'm going to divide both sides by 4. So I know that a times c equals 36. So we could have a variety of things. A could be 1, c could be 36. Maybe a is 9 and c is 4. Or maybe a is 2 and c is 18. We don't know. Those are just a couple possibilities. Let's try another one. Let's see, come up with some values that would give us two imaginary solutions. So again, it'll be the discriminant, but to be imaginary, it was less than 0, so it'd end up taking a square root of a negative in the quadratic formula. B was negative 12. All right, I'm going to add the 4ac to the other side, and then divide by 4. So a times c has to be bigger than 36. So what if a was 4 and c was 10? That would be 40. That's bigger than 36. Or maybe a was 5 and c is still 10. That way, when we multiply those, you get 50, which is bigger than 36. So there's an infinite number of possibilities. Those were just a couple of possible answers. In our real-life problems, or the word problems, the height of an object that's hit or thrown up or down can be modeled by this function. The height as a function of t, so t is time. It's negative 16t squared plus this is the v0 is the initial velocity and s0 is the initial height. We take physics, you should recognize that. Anyway, so you'll have some word problems where they have you plug in some initial velocities and initial heights and find t's and so forth.